Good day, students. This time we'll be having another lesson in mathematics in the modern world. This is your instructor, Mr. Japheth and Nabaira. But before that, take note of these two important features of the EMODULE. The first one is the checkpoint. If you will see this feature across the EMODULE, it conveys that you have to check your progress. It could be a practice exercise, a drill, or a thought-provoking question that will solicit your answer to better understand the topic discussed. Another feature of this EMODULE is the key to correction. This feature in the EMODULE will give you immediate answers to the questions that are posted in the checkpoint section. No explanations will be provided to generate your own justification of the answers, hence enhancing your creativity and critical thinking abilities. That's why you really have to take note of these two important features of this EMODULE, because these two features might pop up in any part of the EMODULE to check your progress. Alright, this time we'll be discussing EMODULE 4.2, Probability and Normal Distribution. For the learning objectives, at the end of this lesson, the student should be able to recognize the normal distribution and its properties and apply the empirical rule and the standard normal distribution to relevant problems like probability. As an overview, the normal distribution is the most important and most widely used distribution in statistics. It is sometimes called the bell curve or the Gaussian curve after the mathematician Carl Friedrich Gauss. As you browse the history of the normal distribution, although Gauss played an important role in its history, Abraham de Moivre first discovered the normal distribution. The shape of the normal distribution depends on the mean and the standard deviation. The figures to the right illustrate two normal distributions with the same mean but different standard deviations. As you can see, these two figures to the right has the same mean, but the figure at the bottom has higher standard deviation. That's why it is more spread. As the standard deviation increases, the distribution becomes more dispersed or spread out, but retains its symmetric bell shape. As you can observe, both of them have different standard deviations, but still they are symmetric with respect to the mean. Did you get it? So we'll be exploring more of this normal distribution. Now, what is a normal distribution? It forms a bell-shaped curve, like that in the picture, that is symmetric about a vertical line through the mean of the data. So imagine that the line in the center of the bell-shaped curve is the mean of the data. And a normal distribution is always symmetric with respect to that line in the middle. Now, the normal distribution provides a wonderful model for all kinds of phenomena because many sets of data items closely resemble this population distribution. Examples include heights and weights of adult males, intelligence quotients, price paid for a new car model, and lifespans of light bulbs. There are many other sets of data that resemble the normal distribution aside from the given here. To continue, we have here the properties of a normal distribution. The first one, the graph is symmetric about a vertical line through the mean of the distribution. Based on the normal distribution in the picture, our mean there is 150. If you're going to draw a line there, the graph of the normal distribution is symmetric to that line. That means whatever part of the distribution can you see in the left side of the distribution is the same or is reflected in the right side. That's why it's symmetric. Now, the mean, median, and mode are equal. Basically, if our mean is 150, the median and the mode is also 150. The third property, areas under the curve that are symmetric about the mean are equal. For example, 120 to 150 have equal area to 150 to 180. Both of them have 34% as their areas because they are symmetric about the mean. Therefore, their areas are equal. Now, the total area under the curve is 1, or in percent, that is 100%. Basically, if you're going to add all the percentage in this particular normal distribution, you will get a sum of 100% or 1 in whole number. Did you get it? So these four are the important properties of a normal distribution. Now, what is the empirical rule for a normal distribution? In other books, they call it 68, 95, 99.7 rule. Why is that so? Take note of this. This normal distribution demonstrates the empirical rule or the 68, 95, 99.7 rule. How are you going to understand that? In a normal distribution, approximately 68% of the data lie within one standard deviation of the mean. So if you're going to observe, the mean there is represented by the Greek letter mu, and our standard deviation is the Greek letter sigma. The blue region there is the area that is one standard deviation within the mean. So basically, you can find 68% of the data in that particular area. Now, from the blue region, if it will extend to the green region, that is now two standard deviations within the mean or from the mean. And if that's the area of the region, the total area is 95% because that is a lot wider than 68% or the blue region, which is only one standard deviation from the mean. And lastly, if you will extend the area until the yellow region, that is now the area to which the data lie within 3 standard deviations from the mean. And the area of that region is approximately 99.7%. That's the origin of 68, 95, 99.7 rule. Or in other books, they call it the empirical rule for a normal distribution. This rule has different usage, and we will use this to solve problems later on. So take note of this. Within one standard deviation from the mean, you have 68% of the data. Within 2 standard deviations from the mean, you have 95%. And when it comes to 3 standard deviations from the mean, you have 99.7%. To continue, let's apply the empirical rule. For example, we have this problem. Male adult heights in a certain city are approximately normally distributed with a mean of 70 inches and a standard deviation of 4 inches. Find the height that is 2 standard deviations above the mean and 3 standard deviations below the mean. So in our given, our mean is 70 inches and our standard deviation is 4 inches. So let's answer together these 2 questions. Using the normal distribution or the empirical rule for the normal distribution, the first question, 2 standard deviations above the mean, that means based on the empirical rule, the height that is 2 standard deviations above the mean is, we have the mean plus 2 times the standard deviation sigma, where mu is the mean and sigma is the standard deviation. I just wrote there ST for short notation for standard deviation. Is that clear? Now, Since we're looking for the height that is 2 standard deviation above the mean, so that height is equal to 70, which is the mean, plus 2 times 4, because our standard deviation is 4. Then that will become 78 inches. Hence, a height of 78 inches is 2 standard deviations above the mean. Do you understand how to solve it? Using the empirical rule? Alright, let's answer letter B. In letter B, we're looking for 3 standard deviations below the mean. Now, based on the empirical rule again, the height that is 3 standard deviation below the mean is represented by the mean mu minus 3 times the standard deviation sigma. And that is 70, which is our mean, minus 3 times 4, our standard deviation. 3 times 4 is 12, so 70 minus 12 is 58 inches. Therefore, we can say now that the height of 58 inches is 3 standard deviations below the mean. It's very easy, right? Because when you're asked for 3 standard deviations below the mean, you just have to multiply 3 to 4, which is your standard deviation, and subtract it to the mean 70. But if you're asked for above the mean, you have to add it to the mean 70. Did you get it? Alright. It's now your turn to check your progress. Now the scores in a test are normally distributed with a mean of 100 and a standard deviation of 20. Find the score that is 1 standard deviation above the mean and 2 standard deviations below the mean. It's very easy. If it's above, you just have to add. If it's below, you just have to subtract from the mean. You can pause this video for a while if you want to solve it accurately and analyze the problem carefully, and then you can play it again for you to view the correct answers. Is that clear? Alright. So I think you have now your answers. So here is now your key to correction. For 1 standard deviation above the mean, of course, that is 1 times 20 plus 100, 120. For 2 standard deviations below the mean, of course, that is 2 times 20 minus it to 100, and that will give you 60. This is very easy, right? Let's continue. Now, let's apply again empirical rule, but this is a different type of problem. Male adult heights in a certain city are approximately normally distributed with a mean of 70 inches and a standard deviation of 4 inches. Now, find the percentage of men with heights between 66 inches and 74 inches, between 70 inches and 74 inches, and above 78 inches. This time, it's not the actual height that is asked, it's the percentage. But we have learned earlier the 68, 95, 99.7 rule, right? So basically, if you're going to write or convert the given data in a normal distribution, we have a mean of 70. So that's in the middle. Since the standard deviation is 4, of course, the gap of every point in the normal curve is 4. So 1 standard deviation above the mean is 74, 2 standard deviation above 78, 3 standard deviation above 82. 1 standard deviation below 66, 2 standard deviation below 62, 3 standard deviation below 58. Now for the first question. Find the percentage of men heights between 66 inches and 74 inches. Let's answer that. Okay, between 66 inches and 74 inches. Solution. We know that 66 is 1 standard deviation below the mean, and 74 is 1 standard deviation above the mean, because that is 70 plus 1 times 4. Using the empirical rule, 68% of the data items fall within 1 standard deviation below and above the mean 70. And you can see it in the figure, because 66 to 74, the area there is 68%. Hence, using the figure and the empirical rule, we can say that there are 68% of the male adults that have heights between 66 inches and 74 inches. Did you get it? So what rule did we use to solve the problem? The empirical rule. Now let's proceed with letter B. Between 70 inches and 74 inches. Now, we know that 70 is our mean, right? And 74 is 1 SD above the mean because 70 plus 1 times 4 is 74. According to empirical rule again, only 68% of the data fall within 1 standard deviation above and below the mean. Now, in our question, we're only looking for 70 inches to 74 inches. That is 1 standard deviation above the mean, and that does not include 1 SD below the mean. Hence, this shows that only half of 68% or 34% of male adults have heights between 70 inches and 74 inches. So the answer is 34%. Do you understand? Alright. Let's have letter C. Above 78 inches. Now, we know that 78 is 2 standard deviations above the mean. How? Because that is 70 plus 2 times 4, which is 78. According to the empirical rule, 95% of the data items fall within 2 standard deviation above or below the mean 70. Since we're only looking for above 78 inches, then we don't need the data 95% because above 78 inches means above the 2 standard deviation. This shows that 100% minus 95% is equal to 5% of male adults have heights above and below the 2 standard deviations from the mean. That includes from 78 and above and 62 and below. But since we are only looking for above 78 inches, and that is only half of 5%. That means because of symmetry, only 2.5% of the heights will be above 2 SDs from the mean. And we know that above 2 SD is also the same thing as saying above 78 inches from the mean. Therefore, only 2.5% of the men have heights above 78 inches. Did you get it, everyone? Alright. I think it's now again your turn to solve the problem. This is the same problem actually. Male adult heights in a certain city are approximately normally distributed with a mean of 70 inches and a standard deviation of 4 inches. Find the percentage of men with heights between 62 inches and 78 inches. Letter B, between 70 inches and 78 inches. Letter C, above 74 inches. This is very easy because we have a graph earlier showing the empirical rule, and that will guide you to come up with the correct answers. Is that clear? Again, you can pause this video for a while for you to compute the percentage accurately, and then you can play again the video to view the correct answers. Is that clear? Alright. I think you have now your answers. So here's now your key to correction. For letter A, between 62 inches and 78 inches, we have 95%. For letter B, between 70 inches and 78 inches, that is 47.5%. And for letter C, above 74 inches, 16%. Do you have the same answers? Alright, so we can continue our lesson now. we'll be moving on to the standard normal distribution. If each data value of a normally distributed random variable x is transformed into a z-score, the result will be the standard normal distribution. As you can see in the picture, the ordinary normal distribution of a random variable x has a mean of mu and a standard deviation of sigma. But if you're going to convert that random variable x into z-scores using z is equal to x minus mu over standard deviation sigma, that will result to a standard normal distribution. And in a standard normal distribution, the mean is 0, the standard deviation is always 1. And the scores there will be the z-scores or the standard scores. We'll be exploring more of this in the next slides, okay? Now, the standard normal distribution is the normal distribution that has a mean of 0 and a standard deviation of 1, as I have said earlier. And this is also reflected in the figure on the screen. Now, as you can see, the vertical line in the middle has a value of 0, and that will represent the mean. Now, the standard deviation is 1. How can you identify that in that figure? Because the gaps between the points in the given graph is 1. So from 0, you have 1 standard deviation to the right, then 2 standard deviation to the right, then 3 standard deviation to the right. To the left, you have -1, -2, and -3. The negative symbol will indicate that the standard deviation is below the mean, or the z-score is below the mean. It is often helpful to convert data values x to z-scores. In a normal distribution, a z-score describes how many standard deviations a particular data item lies above or below the mean. If the original distribution x values is a normal distribution, then the corresponding distribution of z-scores will also be a normal distribution, and that normal distribution is called a standard normal distribution. That is the normal distribution of z-scores, according to Hoffman. See? And that distribution of z-scores will tell us how many standard deviation a certain score is it above or below the mean. If it's above the mean, that means a very good standard score. If that is below the mean, that is not so good because it's below the mean. Now, a z-score describes how many standard deviations a data item in a normal distribution lies above or below the mean. The z-score can be computed using z or z-score is equal to data item minus mean over standard deviation, or the data item represented by x minus the mean mu over the standard deviation sigma. Take note of this. Data items above the mean have positive z-scores. But the data items below the mean have negative z-scores like -1, -2, -3. And the z-score of the mean is 0, and that is constant. Okay? Take note that tables and calculators are often used to determine the area under a portion of the standard normal curve. We will refer to this type of area as an area of the standard normal distribution. Later in this module, we will discover how to find the area of a certain normal distribution. You have in your notes now, Table 1, normal curve areas, the one that I have asked you to bring for you to peruse, and as a reference, that gives the approximate areas of the standard normal distribution between the mean 0 and z standard deviations from the mean. For example, in your notes, Table 1 indicates that the area of the standard normal distribution from the mean 0 up to z is equal to 1.34 is 0.4099 or 0.410 square unit. How are you going to identify that? The area from 0 to z is equal to 1.34 is, you try to find first 1.3. Here it is. And then, since we're looking for 0.34, you find the column of 0.04 because 0.04 and 1.3 is 1.34. So the area now is 0.4099 or 0.410. That's how you're going to find the area in your table, in your notes right now as a reference, because later we'll be using that area to compute for probability. Is that clear? Alright. Let's practice finding an area using symmetry. For example, find the area of the standard normal distribution between z is equal to negative 1.44 and z is equal to 0. Now, because the standard normal distribution is symmetrical about the center line z is equal to 0, you can see it in the graph presented. That is symmetric. The area of the standard normal distribution between z is equal to negative 1.44 and z is equal to 0 is equal to the area between z is equal to 0 to z is equal to 1.44. Why? Because as presented in the graph, the area is just symmetric, and that is one of the properties of the normal distribution. Areas that are symmetric with respect to the mean are equal. Since the value or the area based on your table now in your notes, I hope you're holding it right now, the associated area between 0 and 1.44 is 0.425. Hence, using symmetry, we know also that the area between negative 1.44 to 0 is 0.425 square unit. This is how you're going to use symmetry to find an area. Although the given is negative, that is still symmetric with its positive value 1.44. Hence, the area is just the same. Did you get it? Alright. Let's also have finding area of a tail region. What if you're going to ask for an area in a tail region? Now, for example, find the area of the standard normal distribution to the right of 0.82. To the right, take note. Now, based on your table, the one that you're holding right now, it indicates that from 0 to 0.82, the area is 0.294 square unit. It is also reflected in the figure. From 0 to 0.82, the area is 0.294. Now, since we're looking only for the area to the right of 0.82, we have to subtract the value of the area from 0 to 0.82, which is 0.294, to 0.500. Why 0.500? As one of the characteristics or properties of the normal distribution earlier describes that the total area of a normal distribution is 1. That means half of 1 or 50% to the right because it's symmetric, and 50% is also to the left. Now, since we're only looking for the area to the right, so that means we're only considering 0.5. Hence, to get the area to the right of 0.82, you will subtract 0.294 to 0.5. And the remaining area to the right now is 0.206 square unit. Did you get it right now? It's very easy, right? If you have your table in your hands right now, if you're holding it right now, if you know how to locate the area, then you can use it to find the area of a certain region using symmetry and using half of the area of the normal curve to find the area of a tail region. Is that clear? Alright, so it's now your turn. Let's try to check if you are now adept in finding areas of certain region in a normal curve. Use table 1 or the normal curve areas in your notes right now to find the following areas. First, the area of the standard normal distribution between negative 0.67 to z is equal to 0, and the area of the standard normal distribution to the left of negative 1.47. That means to the left part. So you have also to consider in the second question a 0.5 area to the left. Okay? Now I think it will just consume 2 minutes or 3 minutes for you to answer this question. Again, you can pause this video for a while and then answer this question, then play it again for you to view the correct answer. Is that clear? Alright. I think you have now your answers. So for your key to correction, for the first question, the area is 0.249 square unit. And for the second question, the area is 0.071 square unit. I guess you have now the correct answer. Am I right? Okay, let's proceed. Now let's try to apply the standard normal distribution to probability. In the standard normal distribution, the area of the distribution from z is equal to a to z is equal to b represents the following. First, it is the percentage of z values that lie in the interval from a to b. And we have computed such percentage earlier, right? Using the empirical rule. Another one, that is the probability that the z value lies in the interval from A to B. We can also use area to find probability aside from percentage. Now, because the area of a portion of the standard normal distribution can be interpreted as a percentage of the data or as a probability that the variable lies in an interval, we can use the standard normal distribution to solve many application problems. And one of these is probability. Let's try. Suppose you have this problem. Suppose scores on an IQ test are normally distributed. If the test has a mean of 100 and a standard deviation of 10, what is the probability that a person who takes the test will score between 90 and 110? Okay, so for the solution, let us first compute for the z-scores of 90 and 110. Take note of the given. Our mean here is 100 and our standard deviation is 10. So for us to compute for the z-score of 90, which is negative 1, that is 90 minus mean of 100 divided by the standard deviation of 10, that is equal to negative 1. For the z-score of 110, that is 110 minus the mean of 100 divided by 10, that is 1. So let's try to find out the area from 0 to 1 and 0 to negative 1 using your table in your hands right now. We know that the area from 0 to 1 is 0.341. Can you figure out this area in your table right now? Okay, and since because of symmetry, z is equal to 1 is just symmetric to c is equal to negative 1 in a standard normal distribution. Hence, the area also from z is equal to 0 to z is equal to negative 1 is also 0.341. Since we're looking for the probability that a person who takes the test will score from 90 or between 90 and 110, that means between negative 1 and positive 1. So by adding the areas of 0.341 to another 0.341, the probability now is 0.682 or 68.2%. That is the probability that a person will score between 90 and 110. Did you get it? Do you understand now how to compute for probability using the areas under the normal curve? Alright, So I guess you're now ready for your turn. Please try to answer this question using the area under the standard normal distribution. I hope that you're still holding it right now, the table of normal curve areas. Here's the problem. An average light bulb manufactured by the Acme Corporation lasts 300 days with a standard deviation of 50 days. Assuming that the bulb life is normally distributed, what is the probability that an Acme light bulb will last between 300 to 365 days? Okay, so you can pause this video for a while because I think it will take 2 minutes or 3 minutes. It's very easy. Just find the z-score. We know that 300 is our mean. Just find the z-score of 365. Find the area from 300 to 365 using the z-score. And then, that's now the probability. The question is done. Did you get it? So you can pause the video for a while and play it again to view the correct answer. Is that clear? Alright. I guess you have now your answer. And for your key to correction, the probability is 0.403 or 40.3%. Do you have the same answer? I guess it's a yes. So, take note of this. One of the uses of standard normal distribution. The standard normal distribution can help you figure out which subject you're getting good grades in and which subjects you have to exert more effort into due to low scoring percentage. This is very important because in college life, since you're now first year, you'll be exploring which subject do you perform better and which subject do you perform low. Once you get a score in one subject that is higher than your score in another subject, you might think that you are better in that subject where you get the higher score. But take note, this is not always true. You can only say that you are better in a particular subject if you get a score with a certain number of standard deviations above the mean. This connotes that you have to convert first your score, for example, in one examination to another score that is the z-score so that you can figure out if you have positive z-scores, then you perform better. But if you have negative z-score, you must exert more effort to have positive z-scores next time in that subject. Is that clear? So, I hope you have learned so much in this eModule 4.2. That ends our presentation and discussion of this eModule. If you want to read more about this topic, here are now the references. We also have some online references if you want to browse the internet and learn more about probability and normal distribution. Of course, I have here the photo credits to the pictures and photos that I have utilized in this eModule, especially for the icons. Thank you for listening, everyone. That ends our discussion of this eModule 4.2. God bless and stay awesome.